Okay, so we've been discussing some things that would alter the climate of a planet, and so now we want to talk about eccentricity of the orbit of the Earth. So eccentricity means how stretched out is the orbit of a planet. So if you have something that is a perfect circle, it has an eccentricity of 0. On the other hand, let's say that the star is right there, and now we're going to take this thing and stretch it out. Then we turn it into a ellipse, and so this has a larger eccentricity than what the circle did. And so the Earth, periodically, its orbit changes so that sometimes it's more circular and sometimes it's more stretched out. So what effect would that have on the climate? Well, if it's a perfect circle, then the climate would not change by very much. But if it was stretched out, do you notice that the Earth sometimes would be closer to the Sun? Now this is greatly exaggerated. So the Earth would never have an eccentricity that would be this bad. But you can see that this planet would be closer to the Sun when it's over here, so it would be hotter. And then when the planet was out here, it would be cooler. Now this has a 100,000 year cycle on Earth, so that every 100,000 years the Earth sometimes gets closer and sometimes gets further away. It's not really enough to alter the climate that much, but in combination with some of these other things that we've been mentioning, it could perhaps trigger an ice age. Okay, then the next one is really bizarre. So have you ever been to a amusement park and gotten on an old-fashioned merry-go-round? So the merry-go-round goes around and around, but also the horses go up and down. Have you ever noticed that? The horses are going up and down as they're going around and around on the merry-go-round. The sun does the same thing. So the sun is going around and around the Milky Way galaxy. But the sun is also bobbing up and down above and below the plane of the galaxy. It has to do with gravity. So when the sun is up here above the plane of the galaxy, gravity is trying to pull it down into the plane. So it's pulled down into the plane, but it overshoots it. And then it ends up down here, and then gravity pulls on it again, and it pulls it up. So as the sun is going around the Milky Way galaxy, it's also going up and down. Now, what difference does that make? When the sun is above the plane of the galaxy, it receives more energy that is coming from the center of our galaxy, which we call the galactic bulge. And so that would mean we would get extra energy, so the temperature would be higher. Then when the sun would be inside the plane of the galaxy, it would be shielded from that radiation by the rest of the galaxy. When the sun would be below the plane, we would get that extra energy again. So this has a cycle that takes 10 million years to go through. So it takes 10 million years for the sun to go up and then to come back down and then to go back to its original starting point. Okay, then another reason for climate change is going to be dust. So as the sun is in orbit around the Milky Way galaxy, it's going to take 200 million years. So 200 million years for our sun to make one complete circuit of the Milky Way galaxy. And as it does so, our sun sometimes is going to go through a cloud of gas. When it goes through that cloud of gas, it's going to dim the amount of sunlight that the Earth receives from the sun. And so that's going to make it colder. And then when we come out of the dust cloud, then it's going to warm up. And so this has a 200 million year cycle. All right, let's take a break, and when we come back, let's talk about the movements of the plates.